Oh, I got a remote. Okay. Oh, okay. Got it. Okay. So, oh, okay. Okay. Hello, everyone. I'm Terence from Continuity. Um, so while Suji is putting on the slides, I would like to do a quick survey. So how many of you have heard of Yarn, Hadoop Yarn? Okay. How many of you have used it? One. Okay. It's good. So Hadoop Yarn is a pretty new thing. Sometimes we call it Hadoop 2, if some of you might notice. Okay, so I got the slides. So today is mainly talking about Hadoop Yarn and also a library called Weave that we built to ease the use of Yarn for everyone, developers like us. So, okay. Before I go deep into the Yarn and Weave stuff, so who am I and what the Continuity company doing? So Continuity is actually a startup company that focuses on trying to turning every Java developers or every developers into big data developers. Okay. In order to do that, we build a platform called Reactor platform that allows any programmers can write big data program applications very, very easily. So one of the things that we allow developers to do is what we call real-time stream event processing, like Storm or S4 or the latest Samza. So they're kind of a similar category, real-time stream event processing. And in Continuity, we have something called BigFlow. And it's a real-time streaming event processing, and it's tightly integrated with the Hadoop stack, with HBase as a storage, with Hadoop Yarn as the runtime system. And it has a lot of nice property around it. I'm not going through the details, but it's like transactions on top of HBase that that can guarantee exact event processing for the streams. It's very tight integration with storage in HBase so that you can sure that your data is really processed and precise, like all the standard database durability, atomicity, those kind of things is always guaranteed. And also has a UI for management and really easy application development API. And why I mention this is because all this thing is run on Hadoop using Yarn as a resource management. Okay, so what is Yarn then? Okay, so before I go into Yarn, so many people actually wonder. So now I have a bunch of machines. I have a big Hadoop cluster that can run a lot of MapReduce jobs, which is batch jobs, right? But the question becomes like, okay, I don't have that many batch jobs keep running all the time. Okay, I got some spare resources, or I want to run a different type of programs or different types of things. For example, real-time stream. For example, MPI. There are lots of stuff that I want to leverage the cluster to run. How can I do it? Right? So for example, MPI is a very common programming runtime that you can find on big data. Right? Basically, you iteratively keep processing the data rather than like MapReduce is basically one pass. Right? You map and reduce and that's it. Right? So MPI is like keep doing iterations, and then all the nodes and programs, they can pass message to each other to control, to change the state of the system. It's very common in machine learning, this kind of algorithms. Or streaming apps, as I mentioned, like Storm or the BigFlow, right? It's not a batch job. So basically, the input is keep coming, right? So for example, you want to write something that process web logs of your web service, right? So the logs never stops, right? Because your website is always up, and you keep, getting a lot of logs. You want to do some real-time processing on it, so that, for example, you can base on the clicks and what the user clicks on and what the user sees to compute recommendations for the users. It's a very common use case. Many big companies actually use it, like Yahoo, Facebook. They all based on this kind of real-time stream event processing to give you the news feed, the recommendations kind of stuff. So it's kind of stream event processing. But it does share the properties that you require a cluster of machines to process that like tremendous amount of data in a very resilient way, right? Or you just want to use it to do some distributed load tests, right? You want to test your backend system. Most of the time, you find it like, okay, I use single client, but it's very difficult to load the server, right? So you want to have multiple clients to load the server at the same time. You've got a bunch of machines in a cluster. Why not just use those in a very, if it is really easy, accessible, and easy to use, right? And at the end, what we envision is that you have a cluster that's like lots of machines inside. You can run different type of application on top of it, right? So for example, in this picture, you can see like traditional map modules. You can see real-time streaming. You can see load testing, maybe not in the production system, but in some backend system. MPI, all sorts of programming paradigm that you can implement on top of it. So that's what Yarn come into play. So Yarn, I think the full name is Yet Another Resource Negotiator. Thank you. So basically, it's the resource manager for Hadoop 2.0. In Hadoop 1, I believe most of you will be familiar. Basically, you have the job tracker that do the job, right? So now they basically separate that out into a separate thing. It's called Yarn, and what it does is for managing the resources on the whole Hadoop cluster, and then you can write some applications to ask for resources on the cluster so that it will give you some resources called containers on the cluster, and then you can run your own application in it. So basically in Hadoop 2, the MapReduce is being implemented as one type of Yarn applications, okay? But then you can use Yarn to implement your own type of application as well. So basically, this is what Yarn does. It has a lot of good feature and nice feature for managing resources. Like for example, you can actually run it with LXC or C groups to limit the number of cores or memories for each of the containers. It has very nice scheduler that support preemptions and support like ratios of resources across the whole cluster so that you can submit your job to different queues. And then they give you certain kind of resource guarantee when you run the job, things like that. There are lots of fancy things that build around the Yarn, which is very, very good and important and useful libraries. So I'm going to give a very, very quick introduction to Yarn, since most of you only heard of it. Maybe some of you already know, but anyway. So basically, in Yarn, so you see the pink box. Those are the Yarn components. In Yarn components, there is something called Resource Manager, which is the central piece. Is like a master for managing, who knows about everything of the cluster, everything about the resources of the cluster. And then in each node, there's something called Node Manager that runs locally, which is responsible for launching and managing the containers that run on that particular box. And the Resource Manager will know the existence of the Node Manager and then will communicate with it for acquiring or releasing containers, which are called resources, sometimes called containers. And then, as an application programmer, or let's say you want to write an application that runs on Yarn, what you have to do is you basically have to write two things rather than one, right? Normally, when you want to develop an application, you write one thing, which is your application. But in Yarn case, you have to write two things. The first thing is called an application master. That yellow box, the AM, is the application master, which is responsible for communicating with the resource manager to ask for more resources on the whole cluster to run your actual applications. So to make a very simple example, so let's say you want to run a web server on the Yarn cluster. What you have to do is you first have to write an application master and then deploy the application through the Yarn client, which you have to write some code. It's not a lot, but you have to write some code to deploy the Yarn, to deploy your application master. And then inside the application master, you have to write the logic to ask the resource manager for more containers to run your actual web server. And then you have to monitor those, and then you have to reclaim, like if you want to increase the number of instances or you want to decrease the instances, all those interactions is done by the application master with the resource manager. So basically, you have to write actually quite a lot of code to communicate with Yarn just for that purpose. It's not even talking about your own application yet. But of course, in your own application, you still have to interact with the container a little bit so that it can play, like the whole application can work nicely. And also not to mention the things that are missing, like the real-time loss collections or metrics collections, discovery service. So we find that there are lots of things that developers have to build to make it useful or easy enough to build applications on top of Yarn. So that's why we think that Yarn is not simple, and that's why we come up with Weave. So there are certain pain points that we discover when we try to use Yarn initially. And this is actually the major reason why we try to build Weave, to kind of not letting everyone to go through pain and suffering that we go through, and we try to extract those out as a library. So there are a couple of things. So basically, for anyone, if you try to use Yarn, everyone that we have been talked to is actually pretty difficult. The learning curve is very, very steep. You can easily take like 2 weeks without being able to write any single line in your application. If you have really like trial, you have trial, right? You agree? Oh, yeah. And if you look at the sample applications that are provided by Yarn, 80% or even 90% of the code are boilerplate. So in Yarn, I will show you later, but in the Yarn distribution, they come with examples called distributed shell. As the name suggests, a distributed shell basically allows you to run a shell command across the whole cluster. Okay, that's what it does. And guess how many lines of code it takes for that? Any guess? 100? 500? Yeah? No? So in the example, in the first version that they come up, it actually takes 1,500 lines for that. Okay, and then in later version, they have improved the API a little bit, but it still takes around 1,000 lines for just writing an application that executes a shell command on the whole cluster. Okay, so that's the amount of boilerplate I'm talking about. Right? Effectively, it takes maybe 2 lines or 3 lines of code, right? Including the Java boilerplates, maybe 5 lines of code, right? You can execute a command, but it takes 1,000 lines at least for just doing that. Yeah. And the other thing is, originally Yarn is not built for long-running application. Many of the focus is for running MapReduce job, which it may run for a long time, but eventually it will terminate. We want to use it for running long-running applications, like for example, stream event processing, web service, all sorts of stuff that can be long-running, never ends. So the support on Yarn on running this type of application is not very good. And actually, there's a pending ticket that Yahoo opened on supporting the long-running application in Yarn, especially around the security token things. I can go into details later, but I'm not going into details now. But basically, they're not really built for long-run applications, so it misses a lot of things like log collections, metrics, and real-time monitoring, state transition, those kind of stuff. And well, as I mentioned, there's no standard support for application lifecycle. So all you can do is basically submit a job, it runs, it terminates. That's the things you support, right? But how about you want to increase the number of instances or reduce it, or like pause your applications, do some upgrades? All those kind of stuff are all not supported. You have to do it on your own. That's why you have to write so many code in your application master. And yeah, so basically, and also it's very difficult to debug if you have tried to do it. Because basically the first pain point is when you submit your application, it runs. You don't know whether it succeeds or not. You don't, well, sometimes it fails without any reason, okay? And then you have to go into every single machine to look at the logs in order to figure that out. So it's really, really painful. If you have a cluster of like 20 machines, it's not a big cluster, right? 20 machines. But still, you have to go to like 20 hosts, and then you have to write scripts and then SSH into those. It's really, really painful to do that. And so what we think is we are not trying to tackle like every single type of application. But most of the time, for a typical Yarn application or typical distributed application, what it needs is relatively simple, right? So you have your application. You want to run multiple instances on the cluster at the same time. And then you want to have a way to scale it. You want to have a way to collect the logs and metrics. You want to have a way to discover the existence of them. Like which machine, which port they're running on, right? Those kind of stuff is pretty standard, right? So, and also we think that most Java developers are familiar with threads, right? Writing runnables or threads is very, very familiar to most of the Java developers. So what if we make running distributed applications just like creating a new thread and then you run it, right? That's what we try to do. So these typical lists I've already go through, right? So scaling, long-range jobs, collections, or sorts of things. So that's come with. So with the name, as the name implies, we try to make Yarn in order, right? So it's less messy, it's easy to use. It might not fit every single applications, but at least so far it fits all the applications that we try to build, and we like web server, like real-time streaming, like load testing, like MPI. Most of the applications that we see actually can fit in this model. And in fact, we have like plans or projects that try to start or run HBase on Yarn through Weave as well. So it's kind of an ongoing project. But we are looking at that level of application. So it's not like toy applications, it's real applications that we can run. So, and that's the motivation, right? We try to make it simple, easy, as simple as writing threads using the paradigms that is most familiar to most of the Java developers, already existing Java developers. And we try to hide as many low-level details of Yarn. So what we try to do is when we build an API, we try to make it simple and easy to start with, but also powerful and like powerful enough to like fit in most of the situations. So that's what we try to do. So what we provide in Weave is a very simple set of API. I'll show you right after this, 2 slides after this. And also simplify the way of managing the whole application's lifecycle, like scaling it, terminating it, sending commands, all sorts of things. And also we provide generic application master, which kind of good enough or fit for most applications, not every single applications, but like most applications. And also we try to abstract out some of the pain point that Yarn have to do, like for example, simplify the archive management. I'll go for a little bit more on this one. And also better control on the logging and the errors and the metrics as well. And OK, so I'm always emphasizing on simplicity. This is the level of simplicity I'm talking about. So on the left is the distributed shell example. In here it said 500 lines because we kind of trim out all the boilerplates that are not really core to the application. Okay, so the whole application is like 1,000 lines. If we trim out all those, it still takes 500 lines, the core part that needed for running the distributed shell. If we write the same thing using Weave, the whole program, end to end, like the whole main method, like everything, it takes around 50 lines. That's the level of simplifications that we're talking about through Weave. So how to do that? So we'll look at the API right after this one, but in terms of architecture, basically it's very similar to what you have seen before, right, for the Yarn architecture. But what we provide is something what we call a Weave runner or Weave runner service. That is the client which you submit your application through. And then what you have to construct is basically something for what we call Weave runnable. The Weave runnable is an interface that extends from runnable. And then you implement the run method with some lifecycle method as well. And then you can deploy your runnable and run it on a cluster. When you deploy on a cluster, we also deploy together with the Weave application master that manages the applications. And then your runnable will be shipped to the cluster and run within the container that we get from Yarn based on the specification you set. Let's say you want to run 10 instances of it, then we'll get 10 containers and run 10 instances of your runnable. Or let's say you have multiple runnables that you want to run that contribute to your applications, we'll like do whatever you said, right, based on the specification that you provide. And then we use Zookeeper as the coordination service for the lifecycle and the state management, and also message passing between the client and the application master, and the application master to the actual runnable as well, so that you can actually send a command to your applications. So for example, you want to send some command and change some behavior of your application, you can do that as well. Or you can tell it to stop this particular or suspend this particular runnable and then do some changes and then, to database or whatever it is, and then you resume it. You can do that as well. Okay, so now let's see how the API looks like. So this is the kind of the simplest form. Let's say you want to run a very, very simple thing. Okay, in this example, it's just a toy. Okay, it's the standard Echo server, network Echo server, right? So what you have to do is you just write your class, right, Echo server, just like you used to, and then you implement the with runnable instead of implements runnable. And then you implement the run method, of course, right? And then in the run method, you just do the standard stuff. You start the server, you start listening, and then you bind to it, right? And that's it, right? That's no different than a standard Java applications. That's how your application looks like. The next part is the deployment of the application, right? So we have something called with runner that you construct from the library. So basically, you construct like with runner new yarn with runner, and then you get the instance of the runner, and then you say prepare to run a new Echo server. Okay, so you prepare to run this thing, and then in the prepare method, you actually return like a builder. We call it preparer, that you can like alter the behavior a little bit. So there are a bunch of methods over those, but the simplest thing you could do is, let's say you want to attach a log handler. That's simply just print the logs to your system out. Okay. So in this case, it's just printing. But then, let's say you're running multiple instances of the Echo server across your cluster. You see all the logs in the client. You don't have to go to every single machine to see the logs, right? You see all the logs right away. You have the stack trace. It will point to like exactly where it is, right? Exactly where the logs get emitted. And then after the preparation, you say start. Then your application will start. It will run on the cluster. And after you start, it returns to a controller. So a controller is the interface for you to interact with your applications. So you can stop your applications through the controller. You can send command. Like this case, it send a command to tell the Echo server to change the port that it listens to, for example. Or you can suspend it, or you can like do different things depending on what the controller allows you to do. And that's it. That's the thing. That's the way you build your first distributed applications. So imagine that this is not an Echo server. Imagine that this is a web server, a netty service that you built, right? You don't have to modify your original netty service. All you need to do is to wrap it a little bit with a with runnable. Then it becomes a distributed application automatically. That's the level of simplicity we're talking about. Okay, so the next API I'm going to show is a slightly more advanced case. Is let's say you want to, your application actually consists of multiple runnables. Yes, so this case consists of multiple runnables. How do you construct it? So we have something called a with application, which basically is like a collection. It's like a specification that specifies collections of runnables that you want to run as a single application. Okay. So you basically implement the with runnable and then with application, and then there's only one method that you have to implement, is the configure method that return a specification. And then there's a builder that helps you to build a specification that basically you say there's the name of my application, and I have some runnables. So with runnables, and say so the first runnable I have is a Jetty web server. It's a web server that's using embedded Jetty. Okay, and then the highlight part is when I add this runnable, I can also add with files that will get localized to the container. Okay, so this is very important in the way that, because for example, the web server that you write, when it serves the request, is served from its local directory, right? It's served from its local file system, HTML file, JS, whatever file it is, right? Served from its local file system. But when you run your application on the cluster, you don't know which machine it is running on. You don't know like where it will run. That machine, it may run on one machine, but that one will fail. It will switch over to the other one, right? And so on and so forth. You might be able to like add a new machine to the Yarn cluster, and then you want to add more instances of your applications to run on the new machine as well. So one way to do it, of course, when you set up the machine, you always set up all the files that will possibly be needed by your applications on all the machines. right? But normally, no one will do that, right? So normally what you do is to use a features called localized file in Yarn that basically it can localize any HFS files to your to the local file system of the machines that are in the cluster. Okay, but in order to do that, if you do it through the Yarn API, it's actually not very straightforward and easy. It's like a lot of boilerplate. You can easily like just write 50 lines of code for transporting one files for that. So the Weave API allows you to do that by, let's say you have the files in the client, right, which is pretty typical, right? You can package your file together with your client. And then you say with local files, you have a name for the files, and then you have the path to the file. Then boom, everything under the directory or zip or whatever it is, it will get shipped and become available at the container local directory when the runnable is started. So that you don't have to modify your own application. You can still write your application as reading from local files. You can easily test it without Yarn, without Weave. And then once everything is set, you can deploy it. And then Weave will make sure that the file will be appear in the local file directory. And so you can add a lot of local files, and then you can say apply. And then you can add another runnable. So the log collector, for example, is another runnable, which is a different service that you run on the cluster. But it belongs to part of this web server application as well. What it does, it really depends on what you do. But for this one, it's like, OK, collecting logs from Jetty, for example. You can do whatever you want. You can have arbitrary amount of runnable as well. As long as your cluster have enough capacity to run all those, that would be fine, right? And then at the end, I say any order, which means all these runnable will kind of start simultaneously. Not really simultaneously, because it really depends on the containers that are returned by Yarn. Because the mechanism of working with Yarn is like the application master asks for a container, but Yarn won't give it to you right away. So it's also asynchronous. So you ask for it, and then you keep polling, and then sometimes it might give you one container, it might give you 2 containers. Let's say you ask for 10 containers. This time it might give you 5, next time it gives you 2, and the next call it gives you 3. Okay? So any order basically means whenever the container is available, it will start it. Okay? So we also support, I'll show you in the next slide, but we also support like order starting. For example, you want to say like start this one first, and then start the next one, and start. So we also support that as well. And so now you build your application. You basically start your application in the same way as before. So you have the runner, the Weave runner, and then you prepare your application. You can like still modify the behavior a little bit through the preparer, and then you say start. You get a controller, you can control your application in the same way. This is another examples of showing the applications like the highlight is like the ordering. So you can say first start the reader, and then start the processor, and then start the writer, so on and so forth. So you can specify the ordering of starting of the runnable. Not just one instance of the runnable, but multiple instances of the runnable. So it's not showing this examples, but actually when you add a runnable, you can also say, I want to run 10 instances of this runnable rather than one by one, right? So you can just start it. And also, the API supports something called resource management, which is exactly the same thing that I just said. You can actually set the number of virtual cores that are needed or used by your runnable. But this one is, remember, it's actually virtual cores, which is not necessarily tied to a real CPU core. It all depends on how the Yarn is being configured. It's like a ratio between what you configured and what you say in here. Okay. But anyway, so you can specify the number of cores and the memory size and number of instances, and in future potentially you can specify like the network bandwidth for that as well, because like all those is as long as those are supported by the RxC, the Linux control group, those can be specified through the API, and Yarn, as long as Yarn support it, you will be able to use those as well. And then, so this is the one example. You specify a resource, and then you start things, and more or less the same way, okay? And actually, through the controller, you can also query the resource usage of your applications, because the thing is, even you ask for 2 cores, or even you ask for a certain amount of memory, the Yarn may not give that to you, right? Or it may give more to you, Okay, so you can curate the report for the actual amount of resources that are being used as of that particular moment. So it's easy for you to generate like resource reports, plotting graphs, that kind of things. We are actually using it to generate what we call a resource view for the whole cluster. And also through the controller, you can dynamically change the number of instances for individual runnables. So let's say you want to increase the number of instances of the web service. You can simply just send a change instance command through the controller. Boom, and that's it. It will be done. Okay, so I'm almost time. So roadmap. So right now, the Weave library is open source. We are starting a Apache incubator process. We just started. We hope to get it into Apache incubator so that we can get more and more contributors for the whole thing and build a community around it. So as of the current status, we have released that work with Hadoop 2.0. And then Hadoop 2.1, they just released a version of it that is like 2 weeks ago. We already have and then in Hadoop 2.1, actually they have a major change in the API of Yarn. Basically, they changed everything. So we have a branch in the Weave repository that can work in Hadoop 2.1 as well. We will merge it soon, and then we'll have a version that works with 2.0 and then have another version that works with 2.1 as well. Resource management through C groups, as I mentioned, is in the branch, is working, is planning to merge into developer branch as well. And then down below, there's all like future features that we want to have. And we definitely would love to hear more from the community, like what kind of things that we expect from these kind of libraries as well. So we're looking for like more flexible lifecycle management through the application master. So for example, right now, application master is pretty fixed, fixed logic in it. But we're looking for like adding hooks for you to run some custom logic in the application master so that you can decide, like for example, if a particular runnable or container is died, what you want to do. Do you want to restart it, or do you want to just forget about it, or do you want to terminate the whole applications? So it's slightly different across different applications. So we're looking for like building hooks so that you can write custom code. And of course, we'll have like default configurable. Oh, okay, so by default, it will be like shutting down application, or by default, it will just restart it or something like that. And also, we are looking for like slightly more advanced error handling. Like rather than like always restart or always die, maybe you can keep track of like the percentage of failure, and then like make some decision based on that as well. And extendable application master, as mentioned, we want to be able to allow someone to extend the application master and run your own extension rather than like always run with a fixed version as we provided. Support for long JVM language. So you can see the whole API is like Java-centric. So we're also looking for like long JVM. Well, as of the current version, technically it can run any JVM language like Scala or like Kosher or like anything that can run in JVM. You can kind of run it. You might have to write more code to adapt the class or things like that, but technically it can be run. But we're looking for like running long JVM language as well. Support for more standard command dispatching, because as of right now, the command is pretty custom. So you have to send your own command and you handle it in your own way. Maybe we can come up with some standard command. Well, actually, right now, there's two standard command. One is stopping the application or stopping a runnable. The other is the changing the number of instances of a particular runnable. And also, we're looking for like contributions, and we're kind of working closely with the community. Running HBase using Weave is one of our goals. If you have noticed, there's a project called Hoya, HBase on Yarn, that is kind of similar to Weave, but in the way that they write very specific things for running HBase on Yarn. But in fact, with Weave, you can construct HBase on Yarn pretty quickly. Like you just write two runnables, one for the master, one for the HBase master, one for the region server, and then you just deploy it through Weave API. And also like web server, all sorts of stuff that we would like to have, like to see contributions to the Weave project as well. We'd like to support custom level metrics. Right now, there's no support, so which means you cannot emit metrics and then have the Weave framework to collect it. a better UI, and the last two is the bottom two is kind of like the ability to remote debug. So this one is kind of in far future, it's not in near future, because we would like to see because right now the way to debug is you deploy and then you observe the logs, or you insert logs and see how it changed. But you cannot attach a debugger because the program actually runs on multiple machines remotely. So we're looking for a way to have a way to centralize the debugging and attaching a debugger to the remote applications. And of course, improving the API. Although we think that the current API is good, but we believe when the community evolve, when we have more and more use cases, the API will have need to improve it as well. And so, if you are interested, if you want to start, it's open source is public on GitHub, github.com/with, and then we have lots of docs, documentations with examples in with.community.com. And lastly, we are hiring. So anyone who is interested will think that the things that we work on are cool and useful to the community, useful to big data development. Please feel free to contact us. Contact me through any channel, careers@community.com, or you go to the website or LinkedIn, whatever it is. Okay. We're hiring a lot of positions, engineers. We're especially interested in engineers, senior engineers, big data engineers, platform engineers as well. Thank you. So, do I have time for questions or?
Sure. Any quick questions? I'll pass the mic along.
Terence, can you repeat the question?
Yeah, sure.
Hi. You have mentioned about log aggregation as part of this framework. How do you basically aggregate? Is it based on the timestamp, or if you could talk something about it, would be great.
You mean you talk about the log aggregations? Okay. So the question is, how does the log aggregation works in the with? So basically, how it works is when we start the application master, we start a embedded Kafka server. As you can see in the slides, let me show you the slides back, way back, right here. Oops, right here. So in the application master, right here. So when it starts with a Kafka server. And then when we start the Yarn container, all of them will have a log appenders, SLF4j log appender implemented to publish all the logs to the Kafka server. So the ordering is basically based on the time you publish. So it's not strictly orders across all the containers. You can easily implement a log handlers. So as seen in here. So this one is simply just printed, right? But you can implement your own log handler to do some buffering and sorting before you print it out or before you process it. Because normally when the containers are all up and running, the lag time between the publishing should be relatively small, so within a couple seconds. So you can easily write a log handler that maybe buffer 5 seconds before you flush it out or something like that. But basically that's how it works.
Okay. Do you see these are performance limitations because that is trying to centralize the log?
So as of right now, we don't really see performance issue. First is Kafka itself is really, really scalable in terms of this kind of publish subscription. Second thing is, normally you don't have lots of logs to publish unless you run in trace mode, right? But normally you don't run trace mode in production, right? You only run trace in maybe debugging or things like that, in which performance is not really that important in that sense. So if it's talk about normal logs like info logs or warnings, those kind of logs, it's not really an issue for Kafka. So in LinkedIn, well, actually I used to work in LinkedIn before. So in LinkedIn, they use Kafka to collect all the logs and metrics and everything that's in the LinkedIn website through Kafka as well. Of course, they have a bigger Kafka cluster. But the thing is, the Kafka itself is really, really highly scalable. Yes?
Could you briefly talk about the advantage of running HBase in Yarn?
Running, okay. You want me to talk about how to run HBase on Yarn? Oh, okay. So the advantages of running HBase on Yarn. So the reason for that is, so for example, let's say you have a cluster of machines, okay? You want you want to build a platform as a service, right? So someone would need a Hadoop. Someone would need a HBase. Someone doesn't. Someone want to have a small HBase cluster that comes and go. It doesn't have to run all the time, right? So for example, the HBase is only needed for the lifetime of a particular MapReduce jobs or a particular application only. So you can easily use Yarn or FullWeave, right, to start a HBase, a relatively small HBase cluster on Yarn, and just run it and use it for that particular application. And then you still persist the data, because that's what HBase does. And then you shut down HBase server. The next time the application runs, you start it again. You still read all the old data, but you have the HBase to use. I mean, that's one type of application. The other one is like you're running a lot of different HBase cluster across the whole Hadoop cluster to do like HBase cluster. Yes.
You're able to do it because HBase is not dependent on HDFS, right? It's not dependent. HBase can run on Windows. Yes.
Mm-hmm.
So if somebody needs HBase, then you create another HDFS cluster.
So the question. Right. So the question is, we can do this because HBase doesn't really require HFS. But the thing is, one of the prerequisites as of right now, Yarn requires HFS. So whatever you have Yarn, you have HFS already. And normally I would say when you run HBase in production, you run with HFS. Right? You don't run, well, you can run with some other file system, but I would say majority you run with HFS. And in fact, Yarn does come with HFS. So when you start HBase, you side of Yarn is already have HFS. You don't have to set up another HFS. Yes?
So is there any notion of priority which can be specified in the applications where, okay, these applications have higher priority?
Okay.
And also, there's any notion of work stealing among these couple of applications? Only, is there any way to specify all of that?
Right. So the question is there a way to specify priority for different applications when you try to specify your applications, right? When it runs on a Yarn cluster. So currently, the Yarn allows you to configure different scheduler queue, but it's not really priority because in a way that the schedule queues allows you to specify a particular resource guarantee, and then but you might get more, you might get less, but strictly speaking, it's not really like process priority as of right now. But the Yarn community is actually working something on that. But
Yarn provides a, or maybe it's going to provide it, but they're going to use the same hooks to be able to provide it. I'm assuming you're going to extend those hooks to be able to.
Right. So so as long as Yarn would have those, we'll expose it through the API. But right now, because there's no really standard way or good way to do it yet, so that's why it's not exposed as of the API right now. But yeah, it makes sense to expose those as well, like configuring which queues to run on and the priority of the applications. Should I get PM'd or not? Things like that. Right now, it's not supported through the API yet.
How does Yarn compare with Mesos or the other?
Okay, how does Yarn compare to Mesos? I may not be the perfect person to speak for that. I don't have deep experience in Mesos. All I know is Mesos compared to Yarn is relatively small in terms of the code base and the functionalities. So what Mesos does, I don't know the latest of the Mesos though. So what I know about Mesos is it do resource management, it does it through C groups, and more or less that's it, right? And then you have to build a lot of custom things on top. While Yarn is a much bigger framework, it tightly integrated with HFS, so that it support like local files, as I mentioned, and then it defines like application master, the failure mode, things like that, and also scheduling, not scheduling, but the resource queues and preemptions. It has like more things on top of it. So it's really difficult to compare. One comparison I would look at is Hadoop itself, or the Hadoop ecosystem is a very big ecosystem. It's have a very big community around it. So Yarn is definitely going to survive. It's not going to go away because the whole Hadoop is running on it. The next generation of whole Hadoop thing is running on it. Mesos, I don't know. There's some companies that's starting to use Miso and building things around it, but I don't know how big the community is, like how well it will get developed in long term. But Hadoop, like, I don't have to mention like how big it is, right? How well it gets like funded by different companies, and like big companies actually like Yahoo, Microsoft, Facebook, they put a lot of resources just to contributing, like using it and contributing it back to the community. Any more questions? Maybe last one. If there's
Any more questions? Great. Okay.
Okay. Thank you.